Hello students, welcome to my next video. So we are now going to discuss about the last concept of this particular module, sampling theory, that is chi-square distribution. Okay, so chi-square distribution and chi-square test both are available in this concept. So what do you mean by chi-square distribution and what is this used for? First of all, let us see what is this used. It helps us, the distribution, chi-square distribution helps us to give you a measure of correspondence between theoretical and observed frequencies. What are theoretical frequencies here? Theoretical frequencies are those which are obtained by applying the theoretical methods and getting the results, okay, for a given situation. But observed frequencies are practically what, when a random experiment is conducted, how do you get, what are the results? Those are given by the observed frequencies. Okay, so we will just check the correspondence between the theoretical values and the observed frequencies using this particular distribution. Okay, it's a very helpful tool. And if let us assume that observed frequencies are represented by OIs and the theoretical frequencies are represented by EIs. EIs are nothing but expected frequencies. Okay, observed are OIs. Okay, and we have some n number of trials happening of a random experiment. Now how do we get chi-square chi-square formula? What is the symbol? First of all, the symbol is very important, guys. Just see how to write the symbol. This is a Greek symbol written like this. We'll start on the left top, bring it to the right, a small curve to the right bottom. From left to top to the right bottom, one small curve and one cross line. This is said to be a chi-square and a square on the top. The symbol is chi and the square is said to be a chi-square. This is the notation. So the distribution is denoted by this particular Greek symbol, this one. Okay, so I'll again show you how to write. One curve from the left top to the right bottom and then one cross line and then a square on the top. Hope everyone understood. Anyways, so what is that given by? See, look at this. So once we know the observed frequencies from the data and we can get the theoretical frequencies by applying the appropriate formula for the given situation, what we'll do, we are going to take the difference between these two and take a square of them and divide it by the expected frequencies and the summation of all the n values. How many observations are there here? 1 to n. So the summation of all the m such fractions, okay, is going to give us the chi-square calculated value. Alright, the formula is very simple. Only thing is, like, you got to just get the values, get the frequencies appropriately, put it in this. Alright, now just like your students' T distribution, here also we have something called degrees of freedom given by n-1. What is the use of degrees of freedom? See, in students' T distribution also I told you, we will have a table, theoretical table, or the critical value table, what you call it as, okay, for different level of significance and different degrees of freedom. Like for example, like you will have a column for degrees of freedom like 1, 2, 3, 4 and so on. And here we will have 5% level of significance, 1% level of significance, like that. So at for 1 degree of freedom, at 5% level of significance, some chi-square value will be given here and some value here, and some similarly at 2 degrees of freedom, some chi-square value, and for 1% level of significance, another chi-square value. Got it? Like that. Like this we will have a critical value table. Okay, this is chi-square critical value table. A similar table will be available for students' T distribution as well. And we may have sometimes not just 5 and 1% level of significance. You can have 2% also at in some situations, depending on the given data. Okay, so we will get these critical values for chi-square as well. So for that, the degrees of freedom is used. Okay, so n-1, let us assume our n is 10, so 10-1 is 9. So we'll have to check out for 9 corresponding to either 5% or 1% or 2% level of significance according to the given question. Understood? So that is how it is. Now coming to the another important aspect of chi-square test. So this test is very important tool to check the goodness of fit. Goodness of fit means, let us assume that a data is given and we have to fit an probability distribution. We can fit some different probability distributions. What you guys have studied in the module 3 under probability distributions. What are the distributions that we can fit? Binomial distribution, Poisson distribution, exponential distribution, and so on. And you can have something called uniform distribution. You might not have studied it, but that's also one of the probability distribution. So we have different types of distributions that we can fit for a given data. Okay, now this particular chi-square test, whatever we call, okay, this chi-square test helps us to check the goodness of fit of any of these distributions, whatever we have selected for the data. That means, is binomial fits good, or Poisson is going to fit good, or exponential is good for the data, which is the best. So that we can predict by using the chi-square test. What is this called? Chi-square test. Just like t-test there for students' t distribution, here you have chi-square test. So this particular test allows us to check the goodness of fit for the given distribution. This is the very important tool to check it, and this helps us to analyze the data in the most better way. Understood, students? So this is the theoretical part, and as I told you, the calculated chi-square value always should be less than, this is calculated, chi-square critical value. Chi-square critical value. If it is less than, then only we say that the hypothesis is accepted. If not, if it is not less than chi-square critical value, then we say that the hypothesis is rejected. Understood? So this is the basic theory part of chi-square distribution and chi-square test. Let us see a couple of problems in my next video.